So now we're online. I would say we can just start. I mean, good morning, afternoon, evening, wherever you join to our second SDV CoffeeTalk. My name is Fatih. I'm really excited today. I have Florian and Moritz as speakers here. We will have a very interesting talk, I guess. I mean, the topic is also very interesting. It will be about the early days of Tesla. I mean, probably we can have a short introduction. Florian, you can
yes,
start.
Absolutely. So good morning for me. I'm in Las Vegas. We have early 40 degrees, 106 Fahrenheit, but we're going to go about 10 degrees Fahrenheit higher during the day. So I'm in the automotive industry for about 20 years. The first 7-8 years I was at what you would call the classic automotive world, Siemens Video, Continental, working for Volkswagen and Audi. And then I changed 2012, I changed to Tesla, and I spent a really good amount of time there. And I think we will talk about that quite a bit. So I will not take anything up front right now. But I think that my main goal for here is really just to do a little bit of entertainment, some storytelling. Just take everything with a little bit of bias. Obviously, I'm a little bit of a fan of the stuff we did there. That doesn't mean that everything we did there was the pure gold, but a lot of cool stuff happening.
Cool. Moritz, probably you can just continue.
Yes. So hi, my name is Moritz. I'm pretty enthusiastic about SDV, I would say. I'm working at classic automotive. I'm working with Electrobit these days, and I think it's pretty cool to see how the industry is evolving. I mean, we do see all the EV startups pop up. We do see all incumbent OEMs embracing software. We do see lots of software platforms popping up. And I'm really glad, Florian, to have you here today, because I think we're going to see some really cool insights on what's the difference. What really does anything really set these two types apart? Are there more than two types? And I'm really glad to have you here.
So, Moritz, remind me before we finish that I talk about that update to the windshield wipers you were last time referring to.
I'm really curious about this. I mean, I've heard about this.
I'm getting there. I'm getting there, but let's find the entry point first, and then I'll get to that update.
Yeah, probably we should just start. I mean, casually. I mean, can you just give some overview what you did in Tesla and when you worked actually there and what kind of things you did? I mean.
Yeah, so it was funny. I had my interview actually the day after the Model S started production. So in 2012, I started there in the fall of 2012, and I was the first member and the founder of a team called Vehicle Software or Firmware Validation. So every functionality that is driven by software or firmware in the car went through my team, and we had to sign off on each release. We did like some statistics. We averaged about 150 releases per year. So that's about 3 per week. Tesla is running a 2 weeks sprint cadence. So you have 26 releases planned, and then the other 120 something releases are hot fix or quick fix releases. So the actual release cadence is 2 weeks, and then you have about every regular release has 5 hot fixes going around there. So we were building significant amount of automation, and we integrated all our stuff, our tool chain, in something that was unheard of back in the automotive industry. It's called continuous integration. It was kind of funny because continuous integration was actually published first time in 1988. And the guys around us, they were doing this day in, day out, guys from Apple, Facebook, Google, and so on. And
which year was it? Which year was it? I mean,
2012.
2012, okay.
2012. And we brought in a lot of people. It's Silicon Valley, you know, you have to understand the mindset. There are a lot of people, there's a new company up, a lot of people coming in, they bring some ideas and stuff from the outside. And they came in and said, why are you still doing this old school, like waterfall approach? Why are you not going agile? Why are you not going continuous integration? And we started to look into that. And we were able to build up a machine that goes from a code commit to a fully regression tested vehicle release in less than 1 working day. Obviously for a hotfix, not for a full feature set. Also, Tesla is not developing everything in 2 weeks. That's a misconception. There's a lot of stuff that takes much, much longer. but the actual releases go through the regression testing and all those kind of things, the integration testing, really, really quick.
But was it on a hardware? Was it on a hardware, the testing, or was it on a virtual environment?
I think part of our secret sauce is the integration of all those levels. So you have the tests that run through the CI, so unit tests, static code checkers, miswrite, and all this kind of stuff. You have the large fleet of hill tests for the component level, and then you have the vehicle tests plus a significant amount of simulated tests as well. And all this into one picture, rather than to have it in compartments, right? So when I was before Tesla, I was working as a system test manager. I was always hoping that whatever I'm missing, somebody above or below me in the V cycle is covering, because we never talked to each other. And so we actually merged that all together. It's not that we woke up in the morning and said, that's the way we do it. It's it's a startup. So everybody does everything. And then at one point you say, why would I pull all this stuff apart just to build compartments? Let's just keep it all together and merge it into one picture. And we had this whole machinery going, so that I love to tell the people, it's like when the build manager or release manager came in the morning and said, we have to do a hot fix. Nobody had a heart attack. It's just like, okay, put it in the pipeline. We'll be done tonight.
Oh, cool.
Do you see differences in the types of qualification? I mean, we do see lots of talk about adhering to automotive standards like ASPICE, MISTRA, HIS, all that kind of stuff. And
yes,
I mean, in the supply chain, we see so many proprietary tools for all of that.
Yeah, so it's obviously there are certain standards, and also even though people from the outside probably don't see it that way or don't understand it that way, but Tesla is following a certain amount of standards as well. Tesla is actually fairly process oriented, but they build their own very efficient processes. So because they are the OEM, there is no external audit on ASPICE or something like that. But I happen to go through the ASPICE thing with my team just because the fact that my wife is an ASPICE consultant. And we were fairly close on level 2. So so it's not that we are like Wild West all the way. We were Wild West in 2012, but by the time 2016, 17 area, we reached that. The other thing is that obviously functional safety is treated slightly different than non-functional safety. So those quick releases, those are mostly UI changes or things that are not safety relevant, right? Safety relevant things have also a longer qualification time. And 26262 standard is the guideline there as well.
I can only imagine you have some interesting discussions with your wife at home, right?
Yes, we have topics at lunch that probably normal couples don't have, but it's always interesting.
Just one remark to our audience. If you have any questions, just write the comment. We will just answer the questions during the talk. Just feel free to post your questions there. Cool.
So you've also been with Nio, another EV startup.
Yes.
Is that different from
so
from
first
your
of all
startups?
First of all, I met with both CEOs. That's fairly cool already. And the CEO of Nio, William Lee, is actually a different character. He's much easier to talk to. In general, there was this one story where just like waiting in the line for lunch, and the door to the parking lot opens up, and William Lee walks in and just stands with you in line and is just chatting as like what's new and stuff like this. Nio itself is much more how to say traditional in their structures, while Tesla is very Silicon Valley like and very very fast paced and like fail early, fix early. Nio is more structured and more organized in the classic department structures. So the product is very similar, but the way this product is created is very different. So Nio is also more of an integrator compared to Tesla, who is more a vertically integrated OEM.
So we see a lot of those corporations and partnerships popping up, especially among EV startups, tech companies, and established OEMs. What's your take? What's the secret sauce to actually make something like this a success, and what is bound to fail?
Yeah, this is very interesting. So you can buy technology, but you can hardly buy culture, right? So we've seen this, that companies, startups getting acquired, but the people within a half a year or 1 year, the people are leaving. So you have the tech and you have the name, the brand, but you don't have the workforce. And I think this is exactly what is the difference maker. You have to find a way to keep the culture alive and thriving. And actually the other way around, the startup culture should actually come over into the established company a little bit more. And I got to be honest, I heard so many upper level managers stating they're going agile, stating they allow people to make mistakes, but you don't see it actually happening. And like this, I know a lot of people who were part of those acquisitions and after a few months decided that they don't want to be part of this traditional setup. So I think to answer your question, if you really want that to work, and I'm curious how it will work out between Rivian and Volkswagen now, that is a brand new collaboration. But from my point of view, in order to make that work, you have to keep, this culture separated. And if any cross-pollination happening, let it happen from the startup into the established company and not the other way around. So if the established company will just send over like a group of 100 upper level managers into the startup and try to implement their processes and so, that's never going to work.
But what was you mentioned the culture, the culture is the key point as far as I understood. What was the most different thing in cultural perspective in Tesla than compared to, for example, traditional German companies?
I think this is the point where I can talk about the windshield wipers now.
Okay.
Yeah. Okay. Because, so here's what happened in that story. So first of all, everybody at Tesla, but also Rivian, Nio, and so on, we are on the product, right? No matter where you were in the company, you are on the product. You drive those cars. You know exactly how your product is functioning. Also, I know that in Germany, it's much harder to get that because you have to tax that. You have to get special permissions, driving line, whatever. But in general, we were hands-on on the product. So I drove Tesla Model S together with my wife. We drove up to Lake Tahoe for skiing and we came back. And I realized during the drive down, when you wash the windshield, it wipes 3 times, then it waits a second, and then it wipes another 2 times, and you can't see anything anymore. And so I proposed, and this is a huge difference. So I went into the change control board and I proposed to change this cadence to a 2 and 1 wipe instead of a 3 and 2. Everybody looked at each other and said, you know what? You're right. That is actually a good idea. And starting the next software release, every Tesla in the world was wiping 2-1 instead of 3-2. And this is something where it's like, wow, me as the little mid-level manager, I cannot come up with a good idea, and it actually finds a way into the product very, very quickly.
What was the time? What was the time actually?
Then they changed again.
What was the time actually? If you proposed this and it was implemented, so to say. How
the next sprint?
Oh,
it's
crazy! Oh wow! Oh wow!
Yeah, it's just a parameter change, right? And it's in the next sprint. I was responsible to validate it, obviously, but this kind of small changes. Just imagine you work at a car company XY that's established for 100 years, and you have an idea how you can make your product better. First of all, you would probably not know who to talk to. Second of all, where to find those people, even if you knew how to talk. And third of all, they said, no, we wrote our requirements 8 years ago. We are not changing anything right now. And this is exactly, it's going, SDV is enabling all this kind of stuff. It's not automatically what I say it means SDV, but if you have an SDV approach, you enable this kind of quick adjustments to something better. And with my current car, which I will not mention what it is, but I strongly disagree with the state machine of the body controller, how it locks and unlocks the doors. And I would say that every engineer testing that is like, this is stupid. That should not be like this. But they're not having the option to speak up and say, hey, we can do that better, right? Okay. And so this is the culture, the Tesla culture. And this was just one example. I'll give you another one. Because
how many requirements did you need to rewrite?
So Tesla actually has a slightly different approach. They have a base set of requirements, and then from there on, it's going through change management. So I basically had to write a Jira ticket that actually managed that, and the requirement, that original requirement, is linked to the change management and goes through there. Another story was, so the navigation shows you an arrival time and a remaining time, and you have a clock time, and that didn't add up. So it said like whatever, it's now this amount of this time, and you will arrive in 3 minutes, but that was not coming up mathematically. So I went to the developer of the UI, and I told him, this looks stupid, right? And he's like, yeah, this is just how the math works. He said, you only want that this number plus this number is this number, right? Yes. He's like, okay, done. And that's it. like that. It went in there. You have to understand, in those companies, the UI doesn't have requirement specification. The UI is the requirement specification. This is a very common approach also in web design and everywhere, that the UI itself is its specification. So there were very, very quick changes. Obviously, that had to trickle down through a ticket also into the test world, so that the tests suddenly, don't fail.
How was this? I mean, you mentioned this case with the swipes. This was implemented and it was also rolled out to the older cars. I mean, or
yes.
Only for the new?
No,
it was.
Car.
Oh,
so
okay.
For those who are not familiar, Tesla is still updating the cars from 2012. So obviously
really?
not with the full feature
wow.
set, but the cars from 2012 still receive mainly UI updates.
Okay.
In accordance, obviously, with the hardware capabilities they have, right? So if they have an old chipset in there, obviously they don't get the arcade or the cinema mode stuff, so the movie mode. But they're still getting the refresh UIs, they're still getting the new designs and so on. So even with an old car, and I have a couple of those in my neighborhood here, those people still have the feeling to drive a new car. And this goes all back to the SDV platform enables that. And if you use it or not, that's up to you. I actually, on my car, I got a real cool SDV goodie for 4th of July. I will not mention that right now, but I will post that on 4th of July tomorrow.
Okay.
So you can see that on my LinkedIn profile.
Okay.
But yeah, it's an enablement. So I think, and I saw Moritz agreeing on that. So it's like SDV enables you to do a lot of really cool things. That doesn't automatically mean that you are doing really cool things.
But how much SDV is Tesla actually? How much? I mean, what would you say? I mean, is it fully implementing all SDV concepts? Is it just, what is the ratio? I mean, what do you think?
So Tesla never called the vehicle an SDV. We talked about that before.
Yeah.
So Tesla decided to build the best mobility product that actually was happening to be electric because it was the best solution. It's not that they started and say, hey, let's build an electric car and make it cool. Let's build a cool car and then, let's make it electric, right? And in order to, and now we go a bit back in the day storytelling, in order to deliver their customer experience the way they envisioned it in the time they actually had to go with an OTA approach, because they said we have to give the customers more and more cool stuff, but we don't have it ready yet. So they have to give an SDV approach in there with updatability and so on. Original Tesla cars were completely distributed architecture, so in a classic fashion. Then for Model X, we actually moved into kind of a zonal architecture with actuators dispersed in the car. And then currently they are running more like an actual zonal architecture with front, middle, rear controllers, this kind of stuff. But it's not that we planned it that way and say, let's build an SDV. And actually, I have a quick story when it actually it clicked in the development department. It was somewhere 2013. And there was a problem that the driver for the rear taillights actually was getting too much current and it broke in the customer cars. And technically that was like a KO for the company because they had to bring all the cars back for a recall. But we changed the PWM in the controller to a slightly lower intensity, which was still within regulation. And we did an over-the-air software update and we avoided the recall. And those cars are still around now. When I see them driving by, I see the slightly lower taillight intensity. And at that point, the whole R&D department had this moment. They said, okay, we can do that because we have this stuff in place. We have the power actually to improve our product throughout the user or the ownership. And starting from there, basically, it was like, what else can we do?
Is there a difference in the business operations at Tesla? When I look at like the classic supply chain, right? You buy an ECU and you optimize for bill of materials and you try to squeeze out the last bite of RAM just to get 2 cents off the bomb. And you now talk about let's update, let's make the coolest experience. So what is there a difference?
Well, so first, there's significant difference. First of all, Tesla has very, very few suppliers, basically just like suspension brakes and steering, and of course some chips and stuff like this. Second, they don't run a second source approach. So that makes it easier to run with suppliers, but obviously you have a much higher risk, which they solve in a different way. But also, Tesla has a margin of about 30% plus, give or take. I mean, this is changing all the time, but on the Model S, it was about 30% margin. So that gives you the freedom to over-design your car because you are in a premium segment and the people are buying the higher equipped vehicles anyway. I think we looked at the statistics once and we saw that almost like, I mean, a very large percentage took the fully loaded car anyway, because you know, in 2012, 13, if you buy a car for $100,000 or $110,000, you obviously don't really care too much for that difference, right? And what we then did based on the statistics and the information we had is we decided that we will fully equip those cars anyway, because statistically we are making less loss than we make gain, because then you can also use later in life, you can sell features later, right? So if somebody says, I don't take the autopilot, and you still have the hardware in there, and you can do an upgrade, or as a second-hand buyer, you can do the upgrades. So all this kind of stuff. But we learned that over time. That was not really the very beginning, the strategy that in 2012 we woke up and said, this is how we're going to do it. But we learned that also with a bloody nose here and there, and we also got a lot of statistics and learnings out of information out of this. So we made conscious decisions based on the information we had. And the other thing is that Elon Musk is a very tech-affine person. So he's like, he wants to have the latest stuff in there. And we figure out later what we can do with it, right? I mean, it was one day in 2014, that was before like 3D headsets became a thing. You saw him in the middle of the office with this gigantic 3D headset, and he was looking at a design of a Model X or something like this. I mean, obviously, there was no car there. It was hilarious to see that, but he always said, like, let's go like this. We for Model 3, we almost did no crash testing because we did a lot of simulation, and the first car that actually was crashed, according to my knowledge, was the one at NCAP. So because everything before was like through simulation, and the test results have proven that the simulations were like spot on. So as I say, the management, the leadership at Tesla is always more tech-oriented rather than find the last 2 cents in a vehicle, which has its own challenges, obviously. But it's also the segment they're in. It's a little easier than when you make whatever $300 on your compact car, and you know if you have to spare some hardware for that $300, you're not getting much.
You know, with the smartphone market, I mean, as much overused as the comparison is, the clicking point for the iPhone was opening up SDK, getting a Play Store. Why did Tesla never open up the SDK?
So we talked about that for years, and there's a couple of reasons for that. Functional safety is certainly one of them. Cybersecurity. I mean, those two together, and then Elon usually had this mindset: if there's something that has to be done, we will do it. If we decide that it doesn't have to be done, we will also not allow somebody else to do it. But actually, things have changed, right? So I know that last year or earlier this year, they started to opening up certain parts so that you can actually do some sort of like an app shop. But it was really cautioned a lot by security risks.
There are a couple of questions from the audience. Probably we can just have a quick look on that.
Right.
How do you see functional safety being implemented, realized with SDV?
So it's not counterintuitive. You can easily do that. Functional safety also, or let's say ISO 26262, does not prevent you from doing either SDV or Agile or anything. ASPICE doesn't do it either. And it just needs to be a little tailored in order to work in the cadence. And it is possible. You just have to get away a little bit from this like ultra disconnected development components, right? So you say, oh, we have to open our HARA or the FMEA. Yeah, well then, if you locked the HARA 5 years ago, obviously you have a problem if you do that in an Agile context. But it is absolutely possible. It just needs a little bit of a tailoring. And I saw Moritz some smiles there as well. Maybe he has some pointers.
Yeah, well, I mean, ASPICE certainly is a lot of times mistaken for classic V model waterfall, and you need to all pass it down. And I think this is a big misunderstanding. And I mean, also like the granularity to which you require tracing and these kind of things, there's a lot of flexibility in there. And I really perceive it as it's a guideline, and you need to see where you actually reduce risk for the final product, and not trying to adhere to a wholly specification that needs to be followed like a ritual because we've always done it that way, right?
100% agreed. I'm glad you say it exactly like that, which is exactly how I would say it too.
There is another question from Robert.
Oh, hi, Robert.
How do you do testing at Tesla, actually? Is it dev doing all the tests from unit to vehicle, or do you split the testing activity on specific levels?
Yes, the latter. So actually, the whole development is usually driven by a systems engineer, or they call it the integration engineer, and they are coordinating. So the unit tests are part of the developer's responsibility, and they're integrated in the CI. Then you have the component teams itself are responsible for their component validation. We had a centralized infrastructure team that was part of my team that was building all the test infrastructure, the hills and the tool chain, but the teams had their test engineers using those tools. And then on the integration level, so it's only those three levels basically, unit, component, and then vehicle. And the vehicle level was on my level, where we did test the integration and also the real world performance and physics and stuff like this. And then, as I mentioned that earlier, we merged that together into one picture. And the orchestrator is usually the system engineer that sits over there. And then this system engineer it's a rare find. So we had a few of those, and so they were writing the requirements, they were project managing all those what I just mentioned, including the also the development on the different levels. They did the hardware software coordination, and they actually were sitting in the car with a laptop on their laps and make it work in the end as well. So really specialized engineers. We found those people like in Formula One and stuff like this. This is where we hired them from.
How much was actually manual testing? I mean, how much of this whole chain from code to vehicle, how much was manual and how much was automated?
So for new stuff, there was still a good amount of manual effort, but we did the automated regression testing. So basically everything that is about integration and the integration regressions, and also like performance and stuff like this, for everything that is unchanged, it's almost everything is automated. So from code commit to test results without any humans involved. So there's a Jenkins CI that builds the stuff, tests it, sends it down into the component and into the system, and later collects the results. And we use the Jira database for that. If you have new features or high voltage things and stuff like this, there's a very, very large amount of manual testing involved for safety reasons, but also it did not make sense to us to automate it first and then see if it works or not. So we had a lot of manual effort, and because there's also a lot of evolution during the manual testing, things are getting adjusted and changed. So the test engineer and the developer are very, very close together. They usually sit together in the lab and make it work, basically, together with the systems engineer, right? And once that is working and has been proven over a certain amount of time, then it finds its way into the regression test suite, which is then fully automated.
It's like a tinker and automate proof, right?
Yeah, I mean, nobody who is a sane engineer would assume that you have such a mechatronic complex system and you write the requirements 100% correct from day one, right? So if that ever happens, your product is too boring.
Right.
There is another there is another question. I mean, is SDV making cars more expensive with huge upfront hardware costs? I mean,
yes, it does. But on the other hand, also the hardware costs are going down, so that helps the situation a little bit. Because you also have like HP, so high performance compute units coming up, which have much more capabilities for a smaller amount of money. But yes, in general, if you look at the price of a car between 1980 and today, all the technology that goes in there is the reason for that. SDV is not personally to blame for that. Even if you build a car that is not SDV, you still have a lot of hardware and sensors and technology that goes in there. In the end, thinking it around, SDV might actually reduce the cost from those cars a little bit, because you get into a more integrated system, so you don't have so much duplicated like hardware resources spread out all over the car. But obviously the cars are getting more expensive for all the technology that goes in there. That's clear.
What do you think, Moritz, about that? I mean, what do you think about this question?
Oh, I actually was about to ask another thing.
Oh, okay.
Since you started talking about old tech, and you gave us a little teaser up front, tell us about hydraulics.
Oh, you mean the no more fucking hydraulics?
Yeah.
That's actually not old tech. I don't know if you can see. I'm sporting a Model X T-shirt here right now, and you see it has Falcon doors. Yeah. Very important. It's not gull-wing doors, because Falcon doors have an extra joint in the middle, while gull-wing doors don't. But that's an old discussion. So people might not know, but those doors were actuated hydraulically until like just weeks before start of production, and there was a lot of issues, especially with the agility of the doors. So one day Elon Musk walked in and said that sentence, "No more fucking hydraulics." And John, excellent engineer and the chief engineer on that feature, was able to switch that out within days to electric controls. And I think this is a great example of how SDV is actually enabling you, because the modularity, and this thing I think is one very important thing for me, is when you say SDV, modularity is a very important thing, that you can actually change software modules. So what he did is actually he kept the whole like controls, everything. He just changed the actuator module in his software to an electric actuator. Obviously, he saw that coming, so he wasn't completely blindsided. But it's a great thing to see what you can do. The same another example in that direction is that most people don't know, but the dual motor concept was actually kind of like a submarine project. This was not an official project for a while, but because the cars are modular enough in their architecture, they were just able to slap another motor in there and play around with it on the weekends.
We need more motors.
Yeah, you can never have enough motors. I think quad motor is the latest. I'm wondering where they put the fifth motor at one point.
Talking about modularity, and you mentioned that we're still seeing software updates for the old Teslas.
Correct.
Let's talk about backwards compatibility, software platforms, updatability, and how to make these things work.
How much time you got? No, joking. So the thing, the way they solve that is rather smart. Their cars are a significant partner in that update process, and they have what is called a manifest, and they know exactly what kind of hardware and capability they have in the car. The software package, most people don't know, but there's only one package for all the Tesla cars in the world. Respectively, there's one for SX and one for 3Y. The package contains everything, and the car pulls out what it needs to use. So if you do a change for a car from 2012, you have to change the hardware version, the software for the hardware version of 2012. This will update in the package, and the car from 2012 will just pick that right thing out there. Obviously, it has to go through a validation and interface checks and everything. But like this, the configuration management is like the unsung hero, I think, of Tesla, and the orchestrator behind it's called the Tesla Garage. It's like a website. This is the unsung hero of the company, because everything that I explain here is working through that. And what most car makers getting a little shocked when I tell them, every member of Tesla R&D can do a software update over the air with 3 mouse clicks in 3 seconds. Wow. So you pick a VIN, you pick a software version, you click go, and that's it. And the car will intelligently install the right software, and you only can install something that is approved for this car and for your level of testing as well. And
does that mean that there's really one baseline for all Teslas?
There's one baseline package. So that package contains a large variety of software versions, but it's one baseline package. And actually, every code commit creates a baseline. Every code commit. So there's like 20, 30 baselines every day.
Okay.
Oh, wow. Okay. And probably this question, I mean, Michel, he's actually my engineering lead. Michel, asking what are the
main... Did you feed him that question then?
No. He's asking what are the main test automation challenges in SDV actually? I mean,
so test automation, from my point of view, from when I as a consultant now, I'm talking with all the other car makers as well. It's very separate. There's a lot of separation between the different instances of testing they have. And test automation, most people really talk about automated test execution. And from my point of view, test automation has, as I mentioned earlier, has to start with a code commit and has to end with a test result, including finding the test system, configuring the test system, updating the test system, run the tests, evaluating it, preparing the results, all this kind of stuff. Most other automated tests are usually doing all of this manually and then just press go to run the test and then come back for the results. It's not an SDV challenge per se, but looking at the question more in detail, so SDV sees resources merging together, right? We see certain hardware supporting a variety of functions that wasn't the case before. So the main challenge is really how you organize that, especially if the software that lives on the hardware doesn't come from the same company, right? So if you have a Bosch controller that runs the Siemens and the Conti software on it, it's a huge challenge how to orchestrate all this testing. And it's a question that hasn't been answered yet by the industry. Who is actually doing that? In my opinion, the integrator has to orchestrate that, but they have to change a little bit in their mindset, in their tools, and also in their collaboration. There's projects, and I'm sure Electrobit has a couple of ideas and prototype projects as well, how to work with OEMs on CI. There are some prototype projects out there, but there's no comprehensive solution out there yet.
So we see the concept of software ownership challenged a lot of times these days, right? I mean, I've seen those statements like we need to in-house all software development from various OEMs. What's your take on it?
So as of right now, the OEMs don't have the resources and the skill sets to do so. But I see a large demographic change of software developers moving from tier 1 and tier 2s towards OEMs. That has not been concluded yet, but it is actually there is some change very visible. The challenge that has to be solved is really the integration part, right? So the software, if it's written at the tier 1 or at the OEM, that does not really make any big difference if you don't solve the way how you integrate, how fast you integrate, and how fast you get feedback back to whoever writes the software. And I always say that at Tesla we had only one wall in the office, and that was structural. Other than that, it's like the complete open office concept. And I talked with a couple of folks in San Francisco this week, and it's like, yeah, we see that too at more traditional OEMs and tier 1s, that they start more bringing people together, that they talk and not just sit in two-person offices. I think it's a huge contribution. It's just like this, like everybody is involved in the product and also talking and testing it. No matter if you're a test engineer or not, you should always test your product to see how it behaves.
You being located in Vegas, what do you think about remote work?
I think it depends what you're working on. There's a lot of roles you can easily do remote, and I obviously work remote as well. As a system or vehicle integration and validation manager, I like to be on site because I needed to be on the product. We happen to have a fairly expensive product. So if you develop whatever smartwatches, it's easy to send a smartwatch to everybody who's developing it, no matter where they are located, right? But a car is pretty expensive, so to send a car to every developer, it's getting a little complicated. So I think for some roles, it's really, really helpful to be on the product and in the lab. Not all of them. We also at Nio, actually, we tried to have this idea, and I'm sure you heard it 1,000 times, to put all the test systems somewhere where it's really cheap to have them, and then have them remotely operated by somebody. We spent more time and money actually flying people out there to fix those test systems than we saved by putting them in a cheaper area. So there are ideas and approaches over there, especially with simulation and so on. But in general, I think at a certain level, you need to be close to your product, else you don't get it done right.
I mean, we have a further question from Prashant. How would Tesla approach the transition towards SDV should it were a traditional OEM?
There's almost no answer to that. But if I know Elon right, he would basically throw everything away and start from scratch.
Really?
He does that on a regular basis, right? I mean, the latest FSD 12 point something was a complete rewrite from scratch. So we did. When we did the Model S, we designed the architecture in the way I explained it. And then for Model 3, it's like, no, that wasn't good. Let's scratch everything. We did a completely roboter automated production line for Model 3, $80 million. Everything ran in the basement. And he realized, yeah, that wasn't as good as I thought. Throw everything away. So he would probably just like scratch everything and start over.
Okay. But how is it actually with the Chinese OEMs? I mean, there are a lot of, at the moment or in the last couple of years, appearing brands, and they also do this electric vehicle with a lot of, Tesla similar to Tesla. I mean, how is it actually? I mean, what do you think the quality of the cars compared to Tesla or the concepts? I mean.
Yeah. So here's the fun thing. Actually, nobody cares. The car buyers don't really care for Spaltmaß anymore, so for panel gaps, right? People, yeah, in Germany, outside of Germany, people don't care. People say it's more important to me that I have a karaoke system because I'm in the traffic jam anyway. I want to sing with my friends on my way to work. I don't care if my trunk is like fitting on the millimeter. Moritz, this is not my opinion. This is actually statistical research. But the thing is, traditional car maker have to release the idea of building a car. They are building a mobility experience, and that mobility experience is more than just panel gaps. It has to be a complete user experience, and this is where we see still some gaps for certain things. We see a lot of progress as well. The Chinese companies, they don't have a legacy, right? So they started directly with the user experience at the first point. Many of those companies are started by people who did phone apps or web development or something like this. It was the same with William Lee, the founder of Nio, right? So he was working on transactions through phone apps and stuff like this. So they have a different approach. Their approach is like the usability is first, and then we have to build a car around that.
Okay.
But also, I mean, we here in the US, we don't see Chinese OEMs yet. So next time I'll go to Germany, I will rent one of those cars and I will test them. So mine is just an observation from the outside. I haven't seen the actual perceived quality of those cars.
It's different. It differs between OEMs. There's some that are really good.
So the price is different too, right?
Yeah, and there's some that are really good and some with awful panel gaps, I have to say.
Okay, I mean, if my hand fits through, then I'm in agreement. That's true.
Get a draft when you drive, right?
There is another question. I mean, if there are no restrictions set by type approvals to update, introduce big features of SDV via OTA updates.
So type approvals are valid as long as you don't go below a certain, below the approved, let's say, performance. It's just an example. So there is a way, if you give the car more range, that's okay. You cannot just not go below the sticker, right? There are new regulations, UNEC 156 coming out with the software update management system that actually targets exactly that. But this just went into effect a couple of days ago. Literally. So there's more stuff coming. Right now, it's more, or for the last 12 years, it was more on the self-certification kind of thing. It's like, hey, we give you a type approval, and if you say that you don't go and do something contradicting to the type approval, that's okay. Obviously, it's also the beg for forgiveness instead of for permission American mindset that they do that. But so far it worked out. It worked out pretty well. Here's another interesting thing I wanted to mention, because the EPA here in the US is responsible for the range your electric car has on the sticker, and you have something similar over there. And instead of having every OTA certified by the EPA said we can't come out every like twice a week to certify your OTAs. We actually certified the test bench. And we're able to have a certified, basically a black box test bench, and run a proof, obviously with documentation and everything, that we are not below the range that we actually have approved. And so like this, we didn't have to bring the EPA back. all the time. Buddy, I don't know how strict you are on the 12:15.
Yeah, we are already running out of the. I mean, there are a lot of questions actually. I think we need a second session. I mean, I think we need more.
I'm okay to stick around
so.
for a little longer. I don't know if
yeah,
you paid for the StreamYard for more than that.
No, I mean we can continue.
Let's perhaps take this, the one that we have here on the bottom. What are your thoughts on Android Automotive OS in the context of SDV? Do you believe iOS will dominate the industry? How does automotive grade Linux or any Linux after all actually play a role? What's the role of big open source projects in automotive and perhaps also Tesla?
Yeah, so we see a large paradigm shift in who's playing in this world, right? So we see, I don't want to go exactly into only Android Automotive, but we see, I mean, you see NVIDIA, Qualcomm, all those from a hardware point of view, you see Android, you see Linux, all those players that were not part of automotive until recently. There's always the question about the functional safety. That's why, for example, we don't really see Android Automotive instrument clusters, but we see Android Automotive infotainment screens because they are not safety critical. Instruments clusters ASIL B. But they are working on automotive grade Linux to actually get that certified for 26262 applications. How I'm using Linux, but I'm not such a Linux geek that I could tell you exactly what's going on. But when I talk to Linux people, they roll their eyes and say, I'm curious how they're going to do that, right? But they're working on it. And the way they actually do it, I believe, is they strip away a lot of things. So they really just go down to the kernel and the main like features around it. But long story short, so we will see the whole IoT, internet, or whatever, computing industry merging into the car industry a lot because there's a lot of there's a lot of money to be made. They realize that. And on the other hand, the car industry has to be thankful because they need that technology. They don't have that technology. They don't have the compute power. They don't have the OSs and so on. So I think it's a symbiosis. I think it helps both sides. And it already began. So there's not our decision.
Brings us back to the topic of open SDKs again, right?
Yeah. I mean, more. It's Electrobit has also this Corpus Linux. You know, I mean, what do you think? I mean, you know, this is another variant of.
What can I say? I mean, I don't want to misuse this for marketing, but it's an awesome
solution,
but, right?
I think this is quite interesting because Google is coming with automotive Android Automotive OS. And I mean, you come with EB Corpus Linux. I mean, what do you think? What is the advantage of your approach, actually?
Yeah. Well, so from my perspective, open source in general is when I look at Eclipse, SDV, Covesa, and all these things. We've seen some parts where we've taken open source projects and made them usable for automotive. And I think EB Corpus Linux for us is one of these examples where we've now actually made it usable even in a safety-related context. So this is, of course, something that's rather special from my perspective. When I look at the open source projects that come out of automotive, the question that I always see is, well, how are you going to qualify this? Because all the necessary qualification assets are missing. And we now see these initiatives starting up. When we look at Eclipse SDV, there's now that initiative, that special interest group for qualified development processes for open source. And I think this will be a rather big game changer because once you can actually ensure that whenever you make a pull request, the qualification is still intact. It's exactly the same thing that Florian mentioned now for Tesla, right? So what's not going to work is you take an open source project and continuously try to retrofit qualification artifacts. I mean, it can work for small scale project where you have a very limited amount of contributors, very low change frequency. If you look at big scale communities, I mean, if you take Linux, we see roughly 500 kernel security patches per year. There's no way that you're going to retrofit these kind of commits into a automated way into a qualification process, or you need to take these things out of the qualification path.
But
So
how do you
this is
ensure? But how do you ensure in Corpus Linux actually for safety requirements? How do you because you have to some if this is in the kernel is Linux kernel, right? I mean this is still
yes.
the Linux kernel.
In that case, we specifically take the approach not to safety qualify. So in the end, it's a Linux for safety applications. We make Linux usable for safety applications without requiring to always requalify. So either you need to make the process automatable, which is I think can be done for ASPICE for safety. I'm not really sure. I don't expect that this will really be possible, especially with very high change frequencies, or when you look at Linux, come on, try to include a device driver, prove what happens with your freedom from interference. These kind of things simply don't work that way. So in the end, there's some assets that you really want to take out of a qualification path. When we talk about ASPICE, well, I can see how you can automate a lot of these things, or at least assist in automating this so that you can actually make pull request reviews that check the adherence to the corresponding quality metrics. When I look at the governance of most open source projects, it in the end says, well, please check that your tests run. They don't say, please make sure that his metrics are met, that MISTRA is there, and these kind of things. So this is really something that where I feel a lot of those open source projects need to go, or you really take the approach someone makes an automotive qualified version of it, takes ownership, because it doesn't end with just a pull request, right?
I mean,
the question that you still need to ask, okay, what's the legal liability that someone's willing to assume? What's the organizational capability to update?
Let me chime in really quick before we go too way down into the Linux.
Yes.
No, but you have with open source, you have two options, right? So either can contribute or you fork, right? So that the forking is one option. Then you own it and you have to do everything more. It's just said. We had a fun story actually that we had a contributed open source project, and it was a public GitLab project, and we could not update our test bench because we waited for somebody from that GitLab project to do a review somewhere, and they were in a time zone, they were sleeping, right? So you got to be careful as well when you use open sources, and then at one point you make yourself dependable on somebody else who is not part of your organization, right? So that's the other thing. But as Moritz said, there's a lot of stuff going on. There's no clear answer to it one way or the other. But I think we see a lot of stuff going, and open source is here to stay. We just have to see in what size.
Yeah, but the open source, I mean, I was yesterday also in a meetup about automotive security actually, and I mean, open source is nice, but it's quite difficult. I mean, this is one of the recently famous problems was Log4j, for example. Millions of applications use Log4j, and and then there's a security problem. And
that's absolutely right.
If you, for example, use such a library in a car, which is not always connected, I mean, okay, from time to time connected also. Yeah. This is a challenge, I mean, how
can you secure this? I tell you a fun story. It's a long time ago, and the vulnerability is gone since. But long time ago, if you used a Nintendo proprietary format and played Super Mario Brothers theme song on a USB stick on a Tesla Model S, it opened a certain port that you could actually access the communication through the OBD2 or something. So I don't know exactly. There was a backdoor. Somebody programmed an open source library and used the backdoor, and the key was a Nintendo proprietary format, Super Mario. So it never reached the customer. It was very early stages in R&D. But these are the kind of things you have to be aware of, right? And what is in there, and so the thing is with open source, you really, I think, and then I want to close the open source and talk about other stuff, but you really have to understand what you're using. You cannot take open source black box and it's like, oh, this is solving all my problems. I don't even have to read the code, right? So open source is not free. It requires work and effort.
Yeah, especially life cycle. You have to maintain the whole life cycle. I mean, the dependency. You're depending always on these projects. And some open source projects just has no maintainer anymore after a while. There's no one caring about that.
And now 155 comes into play, right? So, I mean, when you look now at the cybersecurity regulation, you're mandated by law to provide cybersecurity maintenance for 10 years after end of production.
End of production.
How? But
Not
how?
start of production.
So let's take this for 15 years.
Mhm.
How old is the iPhone? Drum roll.
10, I believe. It just turned 10, no?
No, 16 years.
16
so the
years. See,
the first iPhone would have just left maintenance obligation a year ago.
Yeah.
How old are Docker containers?
Less than
10,
that.
10, 12?
12.
Yeah.
12, okay.
So just to put things into perspective, what we're really dealing with here.
Yes.
So who's getting Android maintenance for 15 years today? Who's buying that? These are the kind of questions that will be really, really challenging now in the future.
Exactly, yes.
No, absolutely, you're right. And that's, I mean, we just saw Porsche taking the Macan and the Boxer off the market a couple of days ago for that reason.
Yes.
And I tell people when I in my consulting role, I tell them, you have to be aware what you write today, you have to maintain in 15, 20 years, depending on what product you're going in. And that is a challenge that people have to wrap their head around. Or in other words, it's like, imagine you do a software change on code that was written 15 years ago. And it's like, I wasn't even an engineer 15 years ago, right? So
I recently saw a job posting in Germany from a big German infrastructure
let me guess,
company.
a Fortran developer.
No, a Windows 3.11 maintainer.
I talked to a gentleman on a conference. He was running defense systems, and they were running their test systems on Windows 3. So
wow. Wow. Okay.
Like, whatever you do, don't connect them to the internet. That'd be terrible.
Well, the number of capable attackers will be really, really limited, right?
Yes, that is absolutely true. But in that case, I have another story when it comes to that, because we did in 2017, we did a battery update on the Tesla Roadster from 2009, and I was acting as part-time project manager on that project. And because Elon just wanted to have the longest range EV, was 400 miles back in the day. And we took this car and we put Model S batteries in there. And the biggest problem we had is to actually get the test scripts running again, because they were under Windows XP environment and nobody actually had Windows XP anymore and all the old Python libraries and whatever. So fortunately, one of the test engineers found an old hard drive from like 2010 or something like this, and he rebooted that together with IT, and it was quite an experience.
Wow.
Fun fact is that that very car actually was then later shot into space as a payload for the big Falcon rocket.
Okay. Oh, wow.
Yeah, exactly. So I had one more thing on my posting, which people might want to know, because I said the first Model S was a pickup truck. I'm surprised that nobody asked about that yet. But the thing is that usually what you do when you develop a new car, you use an old version of that car and you build a mule out of that, and you develop your new technology. But obviously at that time they didn't have an old version to build a mule. So what they did is they used the Toyota Tundra pickup truck, took the engine out, put the battery in the truck bed, and put the motor on the rear axle, and that was the first mule that was still around. I mean, it wasn't used anymore, but it was still around in like 2014. So that's why the first Model S was a pickup truck.
Oh, wow. Okay.
It hasn't been driving for 2 years in 2014, but it was still in the parking lot.
Nice.
There is one interesting question. Probably we can answer this and then close the session.
Yes.
Do you have an abstraction layer between your software platform, apps, the system, hardware, for handling different hardware configurations?
Yes, 100%. That's exactly what you need to do. You need to have a hardware abstraction layer, so you have software, and this is where the SDV approach actually goes all together, right? You have to have your hardware, your low-level software that controls the hardware, that provides an abstraction layer, and then you have, similar to the computer you're looking at right now. I mean, that tool we are looking at, Google Chrome, doesn't really care what hardware you're running, right? It has an abstraction layer in there. I just make sure there's sufficient RAM, and that's it. That is exactly the way the journey goes.
Cool. Okay, thank you so much, Florian, Moritz. It was really interesting. I think there are so many questions left. Actually, we need the second session, I guess. I mean, after the summer break.
So first, I'd love to do that. Second, I want to say to everybody, send me your questions directly or hit me up.
Put it in the links on LinkedIn. We can actually answer right on LinkedIn for everyone there.
We do that. Also, please, everybody, connect on LinkedIn. We're not on TikTok. We don't want followers. We want connections. We want to build up a network. So everybody, right now, go and click those 3 dots and then connect. I don't need followers. I want connections.
And if you want to meet up in person, Florian and I will be in the US for the SDV USA in September, and happy to meet you guys there.
Then we should definitely meet after this again to talk about
Absolutely. Let's do that. I think we have plenty of stuff left to talk about.
Cool. Thank you. I mean, I think the SDV Coffee Talk in August will not happen because I'm not there. I'm on vacation. It's vacation time. And we will be back on September. Just stay tuned and see you then. Thanks.
Enjoy your vacation.
Thank you.
See ya.